Okay, so something went wrong with my camera, so I'm just picking up here with example 2. This is from the notes. Alright, I've got to say all this again. Okay, so suppose 92 people went on a trip to Colorado. Of those 92 people, 40 went hiking and 65 went skiing. How many must have done both activities? Assuming everyone did at least one activity, so no one sat out and did nothing. Okay, and then I rephrase the question in a more technical sense. Now, the first thing you may ask is, how in the world could there only be 92 total people? Because 40 plus 65 is more than 92. And the answer is that some people must have done both activities. Right? Some people must be counted twice here. Some people must have hiked and went skiing. That's the answer. That's how these two could possibly add to be more than 92. So if we draw a Venn diagram, and actually, let me make sure my camera is still going before okay, it's still going. If we draw a Venn diagram of this situation, how about we call this side H for people who went hiking, and S for people who went skiing. Box around the outside, the universal set, is the people who went to Colorado on this trip, the 92 people. Okay. Okay, so the way we're going to do this is we're going to think about this circle, the H circle, the hiking circle, should add to 40. In other words, there's going to be some number that gets written here, the people who strictly only went hiking, and some number that gets written here, the people who did both hiking and skiing. And together, those two numbers should add to give 40. And likewise over here in the S circle, the skiing circle, the same number will be here, and then whatever this is, those two numbers should add up to give 65. So here's what we're going to do. We're going to say, to figure out what this center number is, we're going to say, well, we're going to say that if everyone did an activity, then we know that we can subtract 92 from the total here, 105. 40 plus 65 is 105. And this number will be how many must have done both activities. So we can subtract here, and we'll get 13. We'll get 13. This is the number of people that did both activities. So that's all we need to do here. And now, that actually is what the question is asking, so at this point we would be done. And if we wanted to be absolutely technical in our answer, we would say H intersect S. What did they want? They want the size of this intersection. How many people did both? But if I want to say how many are in this set, I need the cardinal number. Remember, the cardinal number is those two bars. Kind of looks like absolute value bars, but they mean the cardinal number, the number of elements. So the cardinal number, the number of elements in this intersection of these two sets is 13. So really what I should have is, well, that's fine. It's fine to have a 13 here because it's understood that these sets are numbers of people. So that's okay. Remember, that was an issue in section 2.1, being careful with, if you've got a set of letters, then you need to specify, if you're putting a number inside the picture, you need to specify that that's a number of letters by using this notation with the cardinal number. But since here the sets actually are a number of people, then this is fine. Now let's go a little bit further than what this problem actually asked, because at this point we're done with the problem. But let's go a little bit further just so you understand what's going on here a little bit better. What number would be written here? Well, it would have to be, this whole circle, H, needs to add to be 40. So this number must be 27, because 27 plus 13 is 40. Likewise over here, what must go here? How many people strictly went skiing and not hiking? Well, it must be 52. It must be 52 because 13 plus 52 is 65. Okay. Let's see what's next. Let's talk about the union of two sets. So what if we have a situation with overlapping sets like this? I'll just call them A and B. But I don't want to talk about their intersection necessarily. I want to talk about the entire everything that's going on here inside of both of these sets. We call that the union. The union of the sets. The union of the sets A and B. And we denote it with a capital U. Capital U. Now, it's actually not a U, it's its own symbol, but it looks very much like a U. It's actually, so here's the intersection symbol. This one's kind of bad. It looks like a V. It shouldn't look like a V. There we go. And then, so intersection and union. Okay. Okay. Sorry, 1 second. Okay, so A union B. That's the symbol. This is the picture. This is just what it means in English. It's the collection of everything, both in A and B, the union of things in A and B. Now, the set builder notation is going to be the set of all elements X, such that X is in A. Now remember, intersection was X is in A and X is in B. Back here. That was the intersection. That was this area. Has to be in A and B at the exact same time. So we can't say, we have to be careful about the use of the word and here, because in math, and is strict. It means you have to be here and here. So we can't use that word right here. It's tempting. You look at this and you say, oh, it's things in A and B. No, it's the things in A or B. Or is much less restrictive. Or is much less restrictive. It lets you be here or here. So if I was to say to you that you need to do, to get credit in this class, you need to do the homework and take the quizzes and take the final exam, then it's clear to you that you need to do all three of those things. It's strict. But if I said to you, you need to do the homework or take the quizzes or take the final exam, then it's clear to you that you could just do one of those three and be satisfied in the course, right? Okay, that's not how our course works. You do have to do all three, just using it as an example. So or is much less restrictive. It says you can be out here, or you could be over here, or you could be in the middle doing both. If you did both, that would still be satisfying the or statement. So union, a union is everything in A or B or the middle. But we don't need to specify that separately here because it's understood. If it's in A, then it's in the middle. Or if it's in B, then it could be in the middle as well. Okay, so let's do an example with this. Okay. Example 3. Is this from the text? Nope. It's similar, but this is my example 3 from the notes. I was going to color code all of these lectures, maybe using different colors for examples and whatnot, but it's just not going to work because my markers are going to die, and I'll have to be switching colors anyways, so that's okay though. You're big kids, you don't need color-coded notes. Well, I suppose it does help sometimes, but anyways. Example 3, from the notes, let A equal 1, 2, 3, So we're going to let A equal 1, 2, 3, the set containing 1, 2, 3. B is the set 3, 4, 5. C is the set 6, 7, 8. Okay. We have some questions. Part A says to find A union B. Okay. A union B. Well, I will do a different color for my solution here. A union B is going to be a set. I want to combine A and B. Notice they have a shared element. I am not going to repeat that element. I am going to write it. I'm going to write 1, 2, 3, but I'm not going to write 2 3s because it's the same element. 4, 5. There it is, A union B. For practice, for extra practice, what's the cardinal number of A union B? 5, because there are 5 elements. Okay, how about part B? Find A union C. A union C is going to be the set of all things in A or in C. So 1, 2, just kind of gluing the sets together. There we go. And just for extra practice, it didn't ask for this, but what is the cardinal number of A union C? 1, 2, 3, 4, 5, 6. 6 items, or 6 elements. You get it. Good. What is A union B union C? Sorry, that's supposed to be a union. Sometimes my union symbols, sometimes they look like V's. A union B union C. So we want to do all 3. Well, all we do is combine all 3 of these sets. It's like a set addition, almost. It's kind of like adding the sets together, in a way. So we would say A union B union C. But you don't want to repeat elements. So I'll say 1, 2, 3, 4, 5. That's A union B. Now all the things from C, 6, 7, 8. There we go. And just for extra practice, what is the cardinal number? There are 8 elements. So there's the cardinal number. What else does it ask? Part D says find A intersect B. So the upside down U means intersect. So I want the intersection of A and B. But remember, A was the set 1, 2, 3, and B was the set 3, 4, 5. So take away the things that they don't share. What is that one element that they share? It's a 3. It's a 3, right? That's the only element they share. So what is the cardinal number of A intersect B? 1. That's a 1. Because they only have, because there's only one element in this set. Finally, part E says find A intersect C. Now look at A and C. A is 1, 2, 3. C is 6, 7, 8. Do they share anything? The answer is no. So what is in the set? Nothing. So what is the set? It's empty. The empty set. Because they share no elements. There are no common elements between A and C. So their intersection is empty. And by the way, what is the cardinal number? It's 0. If a set is empty, then its cardinal number is 0. Okay, cool. Example 4. Let's do some more examples with more set operations. So these two set operations, union and intersection, they're almost like addition and subtraction with regular numbers. Not really though. But Kind of. So what we're going to do is we're going to do more practice with these operations, just like you would do when you first learn addition and subtraction. You're going to start doing practice with bigger sets, bigger numbers, and longer expressions. So example 4 from notes. Let u be, wait, I think I'm getting lost here. Oh, no, yep. Okay, so the universal set, let u equal, so that's the universal set, it's not the union symbol, this is an actual set by itself. Set of all elements x such that x is an English alphabet letter. So, A through Z. Okay. Let M be the set of the letters that spell math, so M-A-T-H. So it's not the single word, it's 4 distinct letters. And N be the set that spells money. And what's K be the set that spells investor. Okay. Part A says to find, and now we get some interesting questions. M union parentheses N intersect K. Now, you know how grouping symbols work with addition and subtraction.